So this is a short introduction into decision trees. It's designed to complement the documents that were posted for you on Moodle, which do have thorough steps but can take a fair bit of working through. One of them is a primer, and I've used the simple example from the primer and simply developed it here in the slides for you. So there's the definition of it, or the reason for using a decision tree. And the key points there are that we will use these if there's high costs and risks involved in a decision, and it gives us a graphic approach that combines uncertainties, costs, and payoffs, and gives us numerical values that we can compare. It's a diagram that uses nodes and connecting branches. And there are three types of nodes that you can read there. And shortly we'll show you those in a diagram, an example. This example has been obtained from this particular document. It's been posted on Moodle for you. So let's start with the first decision. It's also called the root node, and we indicate that with the square that just appeared. In this case, we're imagining a meeting where people are putting up three options for developing or not developing a new product. One of them is a smoke and fire detector. And we know from our company research or from the figures put together that it'll cost about $100,000 to develop. Our market research, or our best educated estimate, also suggests that if it succeeds in the marketplace, it'll bring in $1 million. This raises the question of where do these figures come from? Well, you would have to get them from research, market research, putting together spreadsheets of likely costs, likely benefit. You'd have to know your market niche, the size of your market, what the market's doing. So they don't just appear magically. Somebody has to come and produce these, and hopefully they are subject to critical thinking when people produce them. The second product being suggested is a motion detector, which will cost $10,000 to develop, and the person proposing it is suggesting that it would bring in $400,000 if it succeeds in the marketplace. And the third option is to do none of the first two and do nothing. Not develop a new product. You won't make anything, but then again it won't cost you anything either. So there are our three options. We want to know which one. When we take the likelihood or the probability of success or failure into account, which we do when we put in the nodes of chance events or uncertain events. So we're going to take the probabilities into account with our payoff as well. So to indicate that there is uncertainty about the outcome, we put circles in place. So that's called a chance node or a chance event. And in this case, we're just going to say that each of the products has a chance of succeeding or failing. You could use other options, like you might have high level of success, moderate level of success, or a low level of success, and you'd have to estimate the probabilities of those. In this case, to keep it simple, we're just going to say both of the products has a chance of succeeding or failing. And we now want to put in the payoff. So this is the net profit or loss. So what are you likely to make from the thing, but also subtract what it's going to cost you to produce. Some approaches to this include the calculation in the figures on the right-hand side of the diagram, as you'll see. Some of them take in the costs at a later stage. So now we've reached the end of what we want to put on the branches, so we put on terminal nodes or end nodes, and we're going to put in the payoff figures. So our smoke detector, we know that we can make $1 million from it, and it would cost us $100,000 to produce, and similarly with the motion detector, we could make $400,000, and it would cost $10,000. The payoff, the net payoff for the success of the smoke and fire detector is $900,000, but if it fails, our overall cost is minus $100,000. Similarly, there are the figures for the motion detector. And of course, if you do neither of those, there's no payoff, but there's also been no cost. So now we want to compare these three branches and see which one is going to be the best one for us to take. That is going to determine our decision. So we want to put in the probabilities, and you would have to work out these from market research, for some good quality thinking, etc., as we've already said. So we include those there, and they've already been put in, so the chance of success with the smoke and fire detector is 0.5, or 50% if you like, and so on. Our next step is to calculate the expected value. So there's some text about the expected value for you, and you might like to pause the video while you read through that. So we can work out the expected value for each individual branch, but then we work from the right back towards the left and work out the expected value for each chance node. And here we'll work through an example. So that very top branch with the smoke and fire detector succeeding, the payoff is 900,000, and it has a 50% chance of succeeding, so the expected value is shown by that calculation there. And the expected value if it fails is that calculation. It's the overall payoff minus 100,000 times 0.5 gives you minus 50,000. But what we want now is the expected value for the whole chance node. So if we're going to put a figure on that circle, we add those two expected values, and that gives us the expected value for that particular chance node. Using the same process, there's the expected value for the motion detector, and of course the expected value for the bottom branch, where you haven't done anything but you haven't spent anything, is 0. Now the rules with this are your decision, so the figure you're going to use to guide your decision is the highest expected value. So of those three branches, which one has the highest expected value for any of the chance nodes or the decision branches? And the highest value is the 400,000. So despite the risk of failure, the overall payoff, when you take in the probabilities and the payoffs into account, your best option in this case, using this method, is to go with developing the smoke and fire detector. The example posted for you in Moodle also goes on to develop this to put further decision branches on, which gives you a good chance to follow through on what's called the rollback method. But basically we've been doing that in a simple example, and the rollback method is if you have branches that keep extending other decisions out to the right, then you start on the right hand end of the diagram working out expected values, and you keep working back towards the left using the similar process where you are selecting the highest expected value for any particular decision branch. So I commend the written examples, the ones that have been posted in Moodle, to you now to develop beyond this particular simple example.